Today we make an ESP32 Wi-Fi enabled doorbell detector. We need a ESP32 board, which are quite cheap. I think you can get them on Amazon for a couple of bucks each. The jumper cables to connect to the microphone, to the board, and 2 of these small breadboards. We can attach it, making sure that we have the pins in the right place, because it fits perfectly in the middle, so you still have access to the data pins on the side if you put it right in the middle. Then you gotta push that down, and now that's connected. The next step is we want to connect to the analog pin. So if we have a look, we can see an AO analog pin on the very back end, so we can connect to that. Then we also want to connect to the ground and the power pin, 3 volts. So we have our ground on the back side, on the other side. It's connected. And then connect to our power. Alright, so those are the 3 pins that we need. Then let me grab another microphone. Well, I will put the microphone on the other side of the board, just so we have some space to mess around with. And then we want to connect the pins up. So it tells you on the board there's an analog pin on the far left hand side, so we'll connect that. And then we also have our ground and our power pin. So if we go ahead and connect the ground pin, the power, and the analog pin. Alright, so now this part is complete. After that, we need to connect it to the computer. So yeah, now this is connected. If you were to hear the doorbell or trigger the microphone, then you will get a message from Telegram saying that the doorbell was triggered. And with this, there's so many other options that you could actually do. You can connect a camera, for example, so when it hears the doorbell, you can have a small ESP32 camera on the outside, so basically build your own smart doorbell. Or have it light up a light on an LED board, for example, like this. You can trigger the light, and whenever the doorbell goes off, then you would get a certain color light. Then we switch over to the Arduino software, and for the boards to work, depending on which brand you buy, you have to include a Arduino configuration package for the ESP32 boards, and you can just download it from the URL in the input box. Once you have that, you should have the option to select any of the different brands or types of these Wi-Fi boards. This can also be done with a normal Arduino with a Wi-Fi module. And with that, we can start writing the code. I won't make you guys sit through all the code, because it's quite boring, but a basic overview of what I'm going to do is I include 5 different modules. So I include the Wi-Fi module, the ESP32, the ESP8266 Wi-Fi client for Wi-Fi client secure, the Universal Telegram bot, and an Arduino JSON module. The Universal Telegram bot and the Arduino JSON bot you need to download from the package manager, and then you can start defining how the ESP32 chip is going to connect to the Wi-Fi. So there's a couple of variables we have to define. So we need to define the SSID, so the name of your Wi-Fi, and we also need to create a password variable, and this is the password for your Wi-Fi. And then we need to set up the Telegram bot. So to do so, you'd go over to Telegram and start a conversation with a bot name called the Botfather. And in a second, I'll show you how the conversation would look to get your API key. So now that we want to get the API key, as I said before, we talk to the Botfather, and you can send commands with / and then your command. So you start a conversation with /start, and it'll return a long list of commands that are available to use with this bot. In our case, we want to start a new bot, so we send /newBot. He'll ask for a name, and then he'll ask for a username, and you give it both a name, so doorbell, and in my case, door_bell. And then we have to get our chat ID, so our ESP32 module can connect back and know where to send the messages. So you talk to the ID bot, you send it start, and in a similar way to the Botfather, it'll send a list of commands, and in this case you use /getID, and then we can copy that ID back over to the Arduino code. Then from here out, I start defining the logic for the code. So we set up the pins and the LEDs. So when we get a message, it'll turn on the onboard LED for the ESP32 chip, as well as the case of when we receive or send messages. So we set up a message handler. And we also have to tune the sensor pin, so in this case A0. But if anyone is interested in this specific code, you can email me or write in the comments, and I'll send you a link to a GitHub that has the script in it. But basically, you set up a message handler where you define if a pin is triggered, what happens. So you can turn on the LED state, or you can call back to the message handler and tell it to send a message to the chat ID that you listed at the top. And this basically runs in a loop and just continues to wait for the trigger of the microphone, which in my case would be the sound of a doorbell, and then it'll send me a text. But you could use this for anything you want to detect. I think other than that, that should be it. The boards and the microphone and everything, you can find them on Amazon. If you just search for the ESP32 board, and the microphones come in these module packages, so that has a whole bunch of different sensors, which are good for other projects as well. So it's nice to pick up one of those. anyways, yeah, thanks for watching.